Good morning and welcome everyone to week 172 of NSI Days. My name is Dante Guerra, Vice President of Technical Services for NSI Technologies. And today it's my pleasure of hosting a talk entitled Improving Recovery Potential of Existing Wells Through Optimized Stimulation Intervention, presented by guest speakers Efe Ejofolomi and Ivan Moen, both with Commit Well Solutions. Before we get to today's presentation, we do have just a few brief announcements. The first is always a quick disclaimer to remind everyone that these sessions are intended as a knowledge-sharing platform and a forum for discussion amongst industry peers. The content shared during these sessions is copyrighted by the respective guest speaker's organization or by NSI Technologies and is being shared with prior permission. The next is a quick reminder that we do record these live sessions when we have permission from the guest speaker or the guest speaker's organization. And we post these at no cost for you to be able to view and share with your colleagues at any time. So if you want to go back and refresh yourself, you can find these recordings on our website, nsitech.com. Once you get to the website, you'll see a menu bar at the top. Simply click the NSI Days tab. Once you come to the NSI Days page, you'll see a compendium of prior recordings. A quick tip, if you want to find sessions, because there's a lot of them, and I'll show some quick statistics here in a second, but if you use the search function or Control F, if you're using Windows, you can type in keywords from the title or the speaker name or the date, and that way it'll jump straight to your presentation that you're looking for and related presentations if you search by keyword. Last but not least, if you are with us today live, you most likely have already registered for these sessions and have received a confirmation email. There's also a way to register through our website. What I want to remind you is that on the confirmation email after you register, there is a link to add the recurring event to your calendar. So if you haven't done so, I highly recommend adding that calendar event, and that way you don't miss any future Wednesdays. Some quick statistics so far. Our compendium or our library contains 173 presentation recordings of unique guest speakers, ranging over 126 guest speakers from 14 different E&P companies, 44 service companies or diagnostic companies, 14 independents and consultants, as well as 9 members from academia so far. The next announcement is our guest speakers for next week. We'll host Adam McQueen and Tom Watkins from Advanced Upstream, and they will be presenting a novel approach to reducing carbon footprint of drilling and completions through extended reach laterals. So be sure to join us next week for a pretty interesting talk. Now, without further ado, today's presentation, as I mentioned earlier, is improving recovery potential of existing wells through optimized stimulation intervention. A little bit of background on Ivan. Ivan Moen, who is a co-founder of Commit Well Solutions, has over 17 years of oil and gas experience, spanning multiple roles in completion and intervention operations, engineering, product development, and technology commercialization. Ivan holds a bachelor's degree in petroleum engineering from University of Stavanger and an MBA from Rice University. Efe has over 18 years of oil and gas experience in operations, technical sales and marketing, as well as management across a broad range of industries, including energy, software, and technology. He holds a master's in petroleum engineering from Texas A&M and is also an active member of the Forbes Business Development Council and SPE. Now, before we get to the presentation, I'd like to remind everyone, please place your questions and comments in the chat feature, and then we'll be able to get to them during Q&A. Now, with that, I'll hand over control and we can get to the presentation. Welcome.
So thanks, Dante. While we pull up, okay, good, slides are up. So howdy, everyone. So first off, we really appreciate you all tuning in this morning. Before I begin, I'd like to just quickly express our sincere gratitude to NSI, Dante, Alexandra, and the rest of the team for the invitation, but more importantly, for putting up this fantastic sessions on a weekly basis. All right. So let's just jump right into it. So I think we can all agree that the era of expansive capital projects to boost or drive production growth levels, especially in the United States, is over, right? Because our industry is transitioning or pivoting to a more capital disciplined posture. And as a result, there's that push to more cost-effective methods or solutions to drive production levels from existing assets. But in achieving this or to be able to accomplish this, there's a lot of headwinds or challenges that we are facing today. With dwindling well inventory, status spacing, degradation, what we are seeing is ultimate recoveries from new wells underperforming their legacy predecessors. And over 60% of all existing wells or parent wells tend to be negatively impacted by fracture-driven interference, or FDI, based off of a study that was conducted by SLB a few years ago. So you combine both elements and others, it lends to the fact that it would result in an increase in the amount of well interventions or workovers that these wells or these existing assets would require to sustain their production levels, which ultimately increases the operational carbon footprint. So the main takeaway here is the fact that we as an industry have to quickly find a more sustainable way to extract or boost the production recoveries from these existing assets. And that's exactly what we're going to be talking about today. All right, so what we're going to do here is I'm going to spend the first couple of minutes going through a little bit of overview, and then I'll pass it on to Ivan, and he will walk you through what we've successfully done with some of our partners and clients in successfully addressing this challenge. And it's going to be showcasing a couple of very, very interesting case studies that I believe that each and every one of you on the call today are going to find very, very appealing. And then, as Dante said, afterwards, we'll open up for Q&A, and we'll be more than happy to address all your questions that you may have. Okay? Now, when we talk about maximizing or boosting production recoveries from existing wellbores, one of the biggest challenge to that is around formation damage. And that's based off of a recent study that Kimberlite put out a couple of months ago. And based off of that same study, they found that the vast or the most common solution or technology that was readily applied centered around acid stimulation. Now, when we mention acid stimulation, it covers a wide gamut of options, but traditionally people tend to lean more towards acid bullheading, which is basically where you dump a large volume of acid at surface, typically on the backside of the casing, down into the well, with the anticipation of eliminating the damage source. However, I think we all know that that sort of operation has a lot of inherent restrictions or limitations, including the requirement of large volume, and not being able to properly eliminate the damage at the source. And ultimately, as a result, you would have to repeat that exercise every now and then, which increases that operational footprint that we talked about earlier. Now, on the other end of the spectrum, you have focused restim, which basically is a process of delivering an optimized engineered solution or recipe downhole in the wellbore in a pinpoint-like targeted fashion, allowing you to displace that treatment into the formation, eliminating the damage right at the source, and achieving full wellbore coverage. Right? So being able to do that, it ultimately lends itself to the fact that you have sustained production recovery compared to the more traditional bullheading methods. But the main point I want to really highlight here is, regardless of which approach, right, as we try to boost the recovery from existing assets, it is extremely important to, first off, identify the right well, right, the makeup of that well, its profile, and then blending that or matching that with the right technology or approach that is required to achieve that ultimate goal. And that's really what Comitt we've put together over the past 6-7 years with our Excite technology platform that is specifically designed to eliminate all that operational risk and maximize the production recoveries from existing wellbores. So I'll just spend 1 or 2 minutes just to talk about some key highlights. So basically, it encompasses 3 main elements or pillars. So first, we have the integrated engineering workflows that covers the range of candidate selection, picking up the best well, understanding the source of damage or the damage mechanism, and then designing the optimized treatment recipe to address that damage. And then you have the actual operational aspect of it, from wellbore cleanout to also delivering that optimized treatment recipe in a pinpoint-like fashion downhole to ensure that you have full displacement on the formation, eliminating the damage to drive the overall performance. Now, both of these 2 elements are underpinned by various digital solutions that we've put together that facilitates from the engineering perspective to the operational efficiency of the actual execution. So in a nutshell, the Excite technology platform, as I mentioned, is really designed, has been built to drive and boost recovery from your existing assets. So before I hand it over to Ivan, I'd just like to share, this is the last slide, I'd just like to highlight some just key statistics or metrics. So as of today, spanning over the past couple of years, the Excite platform has been deployed pretty much across all the major basins in the United States with a 98% success rate. Now, I know what you should be thinking, how do we define success, right? For us, success rate is defined with 2 metrics, pretty much. The first is the ability to deploy or deliver that optimized treatment recipe downhole without any operational incident. And second is having or observing a positive production uplift post-treatment. So both conditions have to be present for us to classify that as a success. But I'd like to just draw your attention to the figure to the right, where on the vertical axis, it represents the normalized production, monthly production, for all the treatments of all the wells that we've done to date. And the light blue vertical bar represents the preceding 6 months of production prior to the focus re-stimulation. And the dark vertical bars represents the first 6 months of monthly production post re-stim. Now, overall, we've seen an average of about 2.3 times production uplift once we've executed these sort of treatments. But what I would like to draw your attention to is the sustained level of that production uplift. And that's really key. Because if you think about it, if you've been able to identify the right well, you've been able to diagnose the source of damage that is impeding its performance, and you've come up with an optimized recipe that you're confident and know for sure that would eliminate that damage, and then you have the ability to deliver that recipe downhole in a targeted-like fashion, ensuring that you've displaced it into the formation, eliminating the damage at its source, then it goes without saying, or the expectation is, you should see a sustained level of production uplift, right? And that's the whole point of what we're talking about today, right? So just to wrap up before I hand over, like I said, the platform is purely designed to maximize the recoveries from your existing wellbore. So now I'll hand it over to Ivan, and what he's going to do is basically walk you through in more detail on the Excite process and showcase a couple of very, very compelling, interesting case studies, and then we'll bring it back for Q&A. All right, Ivan?
I'm here. Thank you, FA. So if we kind of think about, kind of summarizing what FA was talking about and think about production enhancement here through interventions like we're discussing, if we're going to put it into kind of 4 main buckets here, we think about like your candidate selection and finding the correct wells, figuring, why are they underperforming and how can we treat that? And then ultimately on the execution part, we have, prepping and cleaning out the well bore, and then ultimately delivering the correct treatment downhole and making sure the entire well is treated. If we draw a line down the middle here, kind of on the left side will be your pre-op work. And then on the, execution or the operational side on the right side. And it's one of those where you can have the perfect candidate, but if the operation doesn't work out, then it's not going to be a good project. Or you can have a perfect operation, but if you haven't figured out everything on the left side of the equation, it still will not work out. So everything here kind of needs to work in tandem, which is where our process comes in. And I'll touch a little bit more on the candidate selection side of it. Especially looking at chemical treatment, acid treatments like Effie was talking about initially. So, we have a good database now of all the wells we have treated. We track production data on all of it. And basically, at this level, we are in the production adding back business. So if we look at the example well right here, we have a well bore that is producing nicely along its forecast. And then at some point it falls off that line. And so in this case, if we can identify, why are we underperforming? Is that due to a scaling or any kind of near wellbore blockage? And how can we treat that to make sure we remove that damage? And also, once that's been identified, what is the potential uplift to move back, to add back to the well? So in this case, if we can add back a significant amount of oil here, or a significant amount of production, this becomes a good candidate for what we're talking about. Also on the clean out side and these things, I'm not going to spend a whole lot of time talking about it, but I really want to emphasize the importance of that, because I think going into a well, doing interventions, it's important to have a clean well bore and a well bore that's prepped for a isolation system to go in and deliver the treatments. And so we work, with a couple of clients that have these Afron style systems, and we've had a lot of good success with that. We've had good success using Venturi kind of style systems. And so I think there's different approaches to it, but I think depending on the well bore, it's another thing we want to make sure we pay a lot of attention to before we go in and do the actual treatment. So then let's look at the treatment delivery. And basically, to make sure the whole wellbore gets treated, especially as we go into a lateral and a longer lateral, we want to make sure we isolate the entire well. We isolate each individual stage or each individual zone you want to treat. And so using that, we have the Excite isolation system here that you deploy on tubing. You have 2 packers that will isolate one zone at a time. You activate the tool simply by pumping down the tubing. That sets the tool. You stop pumping, the tool unset. So you run into the bottom of the well to zone 1. You pump down the tubing, you set the tool. You pump your acid from surface. You displace everything downhole. Stop pumping, tool unsets. You move up to the next stage. And in this case, we have a lot of flexibility, kind of how to design this, how to space it out. We can, depending on your wellbore configuration, we can go down to we can treat your original frac stage, or we can even go down in some instances down to the individual perforation cluster level. So we can space packers out basically however we want, and we can divide a whole lateral up into 20, 30, 40, and then 60, 70 treatments, depending on whatever makes sense. And another thing, as we're treating along, because I think that's what's really key in this case, right? It is to make sure we treat the whole lateral, and it is to measure how efficient are we. And so we'll be treating the well, and we have pressure and temperature gauges on the system here that we record the actual downhole pressure between the 2 packers. So that is your pressure at the perforations when we're ejecting into the formation. And then we have gauges above and below the packers as well. So if we are in a situation where you pump into the formation, and we have communication behind pipe to where you cross communicate either to above or below you, that will be picked up by these other gauges. And so with that, once we treat, we work our way throughout our lateral and we keep treating, we basically also map out the entire lateral. We find out where you have cross communication. We can find out exactly how efficient the treatment was. So very often, if we have cross communication, what could happen is that after say 50 or 75% of the acid has been pumped into the formation, at that point we have a breakthrough, and then we can figure out exactly how much acid was put into that part of the lateral. And also another thing you get with this is essentially a map of depletion level. So as you work your way throughout the lateral, you're going to see your injection pressure vary quite greatly. And I'll show some examples of this later on. And so if you're looking to refract this in the future as well, you basically get a map of your level of depletion. So you can focus a refract treatment more to where you have less depletion. And so looking at your efficiency, this is basically, you work throughout your lateral, and then as you have some cross communication, you can back calculate how efficient each individual treatment was for each stage, and ultimately the entire wellbore. So let's go into a couple of case studies on this, and I think that basically will kind of summarize everything we talked about here. And I think the first one we'll talk about is really summarizes what we talked about across the entire platform in terms of identifying a good candidate, identifying the right treatment, and then making sure we deliver that treatment correctly. And this is from the I think from the Midland Basin, the Wolfcamp Formation in the Permian Basin. We have a wellbore here in gray. We have production since this wellbore was brought on. We have, after about 75 days or so production, we see a pretty sharp drop in production here. This is a part of the field where this client had a fair amount of iron sulfide issues. So we're suspecting that's what's happening here. Here they're actually bullheading some acid down the production, down the backside of the production tubing to revive production. And the wellbore is responding nicely to that treatment. I mean, production is spiking back up, but as we're seeing also, it's got a very sharp decline after that. So I think the good news here is we have the right treatment on it. The wellbore is responding to it. The bad news is we haven't been able to treat the entire lateral. So on this one, this is a 1 mile lateral. We shut down the well for about 8 days. We came in, we treated all the 26 stages individually with acid here, lifted production back up, and was able to keep essentially almost like a flat decline, or basically get it back to the original forecast for this well. And that's what Effie was talking about earlier too. When we look at all of our wells, just aggregated together, the production profile before we do a treatment tends to be, downward sloping. In other words, we have a well that's underproducing compared to what it should be doing. And we have a fairly flat production after the treatment, as long as we can get the whole well treated. So I think this is a good example of that. And also in terms of the economics of this, I mean, we have oil production here on the y-axis. In this case, we were adding back about 150 barrels or so a day. That's going to be a very economic project. At the same time, if you take these numbers and divide them by 10, adding back 15 barrels a day is going to be more economically challenged. So this is all going back to the upfront work we have to do to make sure each project is going to be successful operationally and as well as economical. Fracture-driven interaction is another big issue right now in our industry, and I think this is an example of this, where a wellbore was frac hit after about 10 months or so of production. In this case, our client, they cleaned out the wellbore and bullheaded some acid in to try to revive production. And production is kind of working its way back, but they're estimating here we're losing about 40% of so EUR from that frac hit. And so in this case, this is a 30-stage 1 mile lateral. In this case, we went in and we did 30 treatments on this one and got production lifted nicely back. Obviously, I mean, we're in this case, but I think also the really interesting thing here is if you take this production, kind of move it back to the last time, we had similar production levels, we have a decline that is basically back on the forecast of this. I think with that, again, as long as we've identified what's the matter with the well, we can treat the whole wellbore and we can lift production back to where it should be. Another example of this, and this kind of maybe shows more in terms of the flexibility we can do. I think we had a 26-stage completion, the first one, and then we had a 30. Here's a 46 stage interval in the San Andres. Basically, again, iron sulfide is the issue here, which tends to be in the San Andres. Very like the decline here is quite quite early in the early stages, but the client here wanted to go in and treat this one. We did 46 stages here on one run with a tool. Got production back, not like a huge uplift, but essentially arrested the decline and had flat production and brought production back above the curve for the many months following this again. So I think this kind of, to summarize this, I mean, basically identifying a good candidate, the correct treatment, and then making sure the entire well gets treated. We have a very high chance of treating everything and getting production lifted back to the full potential of the well. I mentioned also on the gauges, and I'll show an example here. This is from the Permian Basin. It's essentially 16 perforation clusters that were treated individually. So it's only a 4-stage completion, a pretty short lateral in this case, and a pretty early vintage shale completion too, if you will. But obviously when you fracked this one, you frack 4 stages together, or four clusters together in one stage. We came in and isolated each stage individually. So what we have here, this is the peak injection pressure downhole, hydrostatic plus the applied from surface. And you can see how this varies widely throughout the lateral. So you have probably some evidence of dominant cluster from the original frac and or in depletion. We have evidence of clusters that were maybe not broken down, where you have essentially virgin rock. And so with this, and that kind of goes back to what I was saying, is you keep treating, you also essentially get a map of your pressure regime across the lateral, where you have depletion and where you do not. So if you want to go back in and refrac this, focus on the high points where you have more pressure and where you don't have that level of depletion. So I think that sums up the slides from my side, essentially covering the platform we talked about through candidate selection, through treatment, and then treatment design, and also mostly over on the treatment placement and execution. So we'll put it back and we'll open up for questions.
Excellent. Well, thank you for covering that. It looks like we have a little more time than normal for Q&A, which is not a bad thing. To get to some questions from the audience, the first question is from Neil Stigent. I'm not sure how to pronounce that, but I'll use both. He says, I did not hear economics in the definition of success for the Excite platform. Obviously, I think we all want economical recovery. Can you comment a little bit more on the economics of this targeted stimulation and intervention?
Sure, Ivan, I guess maybe let me take that up, if that's okay. So yeah, Neil, no, thanks for the question. No, you're absolutely right. So that metric we put out there was geared more on the operational side of things. And as Ivan mentioned, the starting point is right at the candidate selection, right? And you saw on that slide, that is really where the economics aspect or benchmark has to be met or exceeded before it even moves further, right? So, and that's key, right? Because at the end, we're all in here to make business or making money, right? And doing it the right way. So if the well candidate or as a project or as a program level, right, it does not meet the economic thresholds that you, your team, you have, then there's no way you can proceed further. No, right? But on that particular slide, I was just talking more on the operational side of things, right? Making sure we're able to execute and perform without any risk, right? Or any related risk incident. And of course, seeing the positive uplift as well. Okay.
I can chime in on that a little bit too. I think I made a little bit of mention on it on one of the case studies, and it kind of comes in on the pre-job prep that you keep screening for candidates, because you want to define what is the potential, the production uplift potential for each well. And so on the well where we could add back 150 barrels a day, running the economics on that made it very, very compelling. But then, like as I made notion of, you take those numbers and divide them by 10, right? If you add back 15 barrels a day, then in that specific instance, that would have not been so economic. That would have been quite economically challenged. And so, 15 barrels a day may work for certain application, maybe on vertical wells or something. On the horizontal well, that tends to be a little bit more challenged. So that becomes quite individual. But at the end of the day, that is essentially why we're doing this whole thing, is to identify that potential for each well and then run the economics for each well as well.
And a little expansion on that same question, or I think it's related to that question. When you're looking at candidate selection, a lot of times, especially in your case studies, you showed difference in depletion along the lateral section, do you require the operator to have information or some kind of diagnostic on the production across the lateral sections, or to identify these sections of re-stimulation or for potential, identify where depletion has happened and where there's more virgin rock to re-stimulate? Can you comment on how you determine these factors if there isn't any permanent diagnostic or PLT available for that well?
Yeah, so I think that the candidate selection, I think the most important thing we're looking for there is to make sure we have a well that is not producing what it should be doing. And I think that comes from especially the early vintage jobs that we did, where we treated wells that were severely depleted, or we would treat wells that would wouldn't necessarily be anything wrong with them, and we would, from an operational standpoint, pull this off quite well, but then we would see a very minimal impact on the production uplift. So as we started gathering data on all the wells we did, this is kind of what we started looking for. So, okay, we're looking for wells that are underperforming. And we have, and we're building now, we have a process in terms of using public data to at least do an initial screening of that, working with clients. We're also getting into some RTA on this to further hone in on, one is identify the well as underproducing, what's causing it, how much production can we add back. So when I look at the level of depletion across the lateral, that's not data we need in this case. That's essentially like an output of the entire process. So we do this whole thing. That also becomes like a deliverable at the end of it. Essentially, one, we could gauge how efficient the treatment was by monitoring this as we keep working our way throughout the lateral. But then, almost like an add-on or bolt-on kind of service, if you will, you also get a map of your entire lateral from a depletion standpoint.
Got it.
But Dante, just to qualify that as well. So to your question, if, for example, we're going in blind, right, without any sort of diagnostic along the wellbore, let's say 2-mile lateral, right? And we've seen, as Ivan mentioned, that look, okay, this is a potentially good candidate. There's a potential to recover, with a significant upside. Now, on the actual placement, right, so going in blind, so the baseline would be, okay, we can go in and hit all the targeted intervals, right? Because we have no insight to at least tell us their discrepancies, right? The other thing we would also infer to is just to how the well originally performed during the completion, right? So we can get a lot of insight from that, right? Looking at all the breakdowns, looking at gradient, frac gradients, all the pressures. Of course, you can get a lot of insight on which stage or interval treated well, right? And that might give you a sense of, okay, maybe more performance or production from that interval versus the other. So we might use that to dial in, let's say, the treatment volume, if you may, from an optimized perspective. But a bare baseline minimum would just be, okay, just to be safe, just hitting all the interval. But of course, with some diagnostic, you can now be more specific, right? And the Excite system allows you that affordability to be that specific, if that makes sense.
No, that makes perfect sense. Now, there's a question on the deployment of this process. It's from Tom Maunder. He's asking, you mentioned deploying on tubing. Do you use coil as well or other deployment techniques?
Yeah, so we need, the tool works off of hydraulics, so we need to be able to pump to set it. So we can pump through tubing or we can pump through coil tubing. So it's whatever really makes sense. We see a lot in the domestic US, we're using a workover rig, tends to be quite economic for this. And so we deploy it on very often on a workover rig. Then we're looking at, if you have some pressure on the well, or, for whatever other reason you want to use coil tubing, that's very doable too. So coil tubing limits you a little bit more in terms of, with the lubricator height and these things, in terms of how much distance you can put between the packers. So it limits a little bit the flexibility on that. But beyond that, you can run this on really any kind of tubing or coil tubing string.
Got it. And now on wellbore prep, there's a question from John talking about case study number 2. Was the cleanout performed to TD or more of a heel check?
Yeah, so it performed to TD. So in that specific case, it was I mean sand obviously coming into the well from a frac kit. So it was cleaned out to TD, and that's also on every. I think operationally, that's maybe our biggest lesson learned throughout this whole process. And as long as we've been running this, has been how to prep the well and making sure we get that correct. Because I think early on we maybe just kind of pushed a bit to bottom, or our understanding of prepping the well was not what it is today. And at that point, you leave debris left in the well bore, and you run in with packers and everything. That's not what you want to have a clean well bore at that point. So figuring out that composition part of it, just from a clean out BHA standpoint, but also from a process standpoint. I made mention of some of these Afron systems on the market. They've been there's only a handful of companies that are actually have expertise on cleaning out depleted wells using Afrons, but we've had very good success with those as well. So getting that process right and making sure we clean out the entire wellbore before you run in with an isolation system, that's very key to success.
Absolutely. I think that was something on a lot of people's minds. The next question from Zeno Philip, he's talking about case study number 1. How much total acid volume did you use for the focus restim as opposed to bullheading?
Yeah, it was quite similar volumes actually. We ended up using a little bit more on the focus restim, but it was the volumes were quite similar on that. And so I think the difference there is basically, I think the initial bullhead did a really good job of stimulating the heel portion of it, probably better so than we did, because a lot of acid went in there versus the rest of it, right? And I think that kind of shows on that production too. But in that case, that acid didn't make it across the entire lateral, which also showed by the time we were able to go and treat the rest of the well.
Yeah. So that, I think it might be good to, if I can interject to the question. I think that was a very good question, because I would argue that in our industry as a whole, when it comes to acid stimulation or restim, one of the big gaps that still exists is the treatment optimization. Right now, we have a good handle on the recipe, right, on what makes sense, of course, with all the tests and all that good stuff. But now, how do you optimize this is the right volume to pump for the particular wellbore condition, right, and damage that exists, right? Majority of it is always best practice, or what has always been done. Compared to on the hydraulic fracturing perspective, that we have locked in, right? We can optimize, we're very comfortable. Well, on the acid restim, it's still sort of, I won't say black box, it's just a void. And that's really something that we are actively working on, as part of our entire platform. And in fact, we're actually partnering up with we all in trying to address that. And just for the audience perspective, we should have something coming out. Hopefully, we'll be doing another follow-up session, really talking about how do you truly optimize your restim volumes depending on your wellbore condition to further maximize your return, right? So that's something you all should look out for, because I think it has a lot of relevance to what we're talking about today.
Absolutely. And we've gotten quite a bit of questions in the comments, so I want to be able to address everyone's questions. So forgive me if I'm going a little fast from one to the next. But Eli L is asking about the dimensions. So what is the ID and OD, inner diameter and outer diameter of the Excite system? Comments if you don't, or you're not able to achieve target rates. And then third part to this question, have you pumped proppant or just acid and chemicals through the system?
Yeah, so the ID and OD depends on which casing we're in. So we have tools for 3.5 casing, 4.5, 5.5, and 7-inch. I'm trying to think if I left anything out, but we can also basically accommodate most things in between that. So obviously OD is gonna, and also ID of the systems are gonna vary depending on that. But on the rate side, the systems are depending a little bit on the size of them, but they're designed usually in the 20 to 30 barrels per minute in terms of what we can get through them. We've been able to pump 30 barrels a minute both through the 4.5 inch and the 5.5 inch systems. So the limitation of it tends to be the tubing that we're conveying this on. And so if we go in either on stick pipe or we go in on coil tubing, that tends to, the maximum pump rate through that tends to be where we get limited in terms of how fast we can pump. But it's a good question on that too, because I think especially if you're pumping proppant, you want to make sure you have sufficient rate. And the way we've done some proppant jobs. The tool is designed for that. We can pump a fair amount of proppant through this. Operationally, that is a more complex job, but we talked about cross communication stuff that we see on our gauges as well. Pumping acid, we're not really seeing any operational issues from cross communication. With sand, that's a whole different issue. So at that point, we want to make sure we have a well where we can get rid of the sand. We want to have all the contingencies in place, but it is definitely possible to pump sand. It's just from an application engineering standpoint, that's essentially where the complexity is on that, to make sure we check all of our boxes before we go into a well and pump proppant.
Yeah, and that actually brings us to a couple questions from the audience related to pumping proppant. One is, you mentioned in your case studies that you're using acids. Do you use all types of acids? What kind of acids were you using? And the second is using this system with proppant fracs for targeted refracturing of wells. So ideally, coming back into a wellbore and isolating those sections in between producing clusters and re-stimulating virgin rock, it sounds like this system might be quite adaptable to such an application. Can you comment?
Yeah, for sure. I can. So on starting on the proppant side, we kind of as I showed with our gauges too. So our approach to that is to initially we'll break down everything with acid. With that, we map out the well and we find out where we have cross communication and where we don't, and then we can go in and do selected proppant treatment. So that's been our approach to that, to mitigate some of the risks associated. On the acid, I mean, we basically, and also other kinds of chemicals, we can pump basically, I mean, at least most chemicals out there. They may be get into something super exotic. We may have issues with metallurgy and whatever, but in general, we can pump pretty much all fluids through the tool. So on the acid side, I mean, it's hydrochloric, we pumped hydrofluoric, we pumped acetic acid, we pumped scale squeeze kinds of chemicals, surfactants, and so yeah. And on the proppant side, we pumped. I mean, if you're pumping proppant, you wanna have some viscosity in the fluid to carry proppant. We have pumped slick water here; it's been okay, but you tend to have more proppant fallout that you need to address at some point using that. So having some sort of viscosity in it definitely helps. So we pumped, linear gel, we pumped cross-linked fluids as well with proppant. So from a fluid standpoint, I think we've basically covered the whole spectra, if you will.
Very good. Now another question related to these kind of re-stimulations coming from Bob Barbet. Bob is asking, what is the typical magnitude of the increase in recovery factor in a typical legacy well with wide cluster spacing? And how would the economics compare of this system versus mechanically isolated plug and perf refrac?
Yeah, so I think Effie can chime in later on if you have some thoughts on that too. But on most of our track record tends to be on doing full well bores is on the chemical side of things. And so what we're seeing is that we can basically get back to, if you do a decline curve analysis, we start with that, the well is deviating from it, we can get back to where the well should be performing. So it's basically, I made a comment on that earlier on, we're in the production adding back business. I think on the refrac side of things, there's for the larger refracs that are being done, operators tend to reline either with an expandable or a cemented liner or something to reline and do plug and perf, and then pump large fracture stimulations into that. And I think that becomes a different application from what we can do in this case, because it through tubing or through a isolation system like this, you're not going to be placing 15 or 20 million pounds of sand. You're looking to do in smaller targeted. And I think on the smaller targeted treatments, running a liner actually wouldn't be economic because that tends to be a pretty high, upfront investment kind of operation. So it falls into two little bit different buckets. But on the acid treatments and stuff, like I said, we're basically we can bring production back at least back to the curve where the well should be producing, as long as we can get the entire lateral treated.
That makes sense. Yeah, thank you for that explanation. It makes a lot of sense to explain, the two different applications. Like you mentioned, one is an entire full wellbore re-stimulation, whereas your application is a lot more targeted precision intervention for certain problem sections, I would say. But sorry, Efe, go ahead.
No, I'm just going to add, yes. So with the Excite system, yes, it's precise and targeted. It could be reaching the entire wellbore. But to back up to, I think it was Bob's question, that's really where the pre-work comes in, right? And that's why we talked about the candidate selection, right? Because even for refracts, right? I mean, I've done refracts for quite some time, right? Not every well is a good refract candidate. No, right? And that used to always be the problem. We thought we could refract everything, but then we got inconsistent results, right? So it all depends on how do you qualify that particular well. And I mentioned this during my talk, is qualifying the well you have, right? Understanding what recovery are you trying to achieve from those wells, and then matching it with the right or the appropriate technology to bridge them together, right? And on the refract side, I think from a refract candidate selection, I think as an industry, it's sort of mature. I think we have a lot of experience and maturity around it. However, on the re-stim side, I think there's still a big level of immaturity when it comes to understanding the qualifications or selection on which sort of well would really fit that sort of re-stim enhancement opportunity. The capital investment is not as severe or as heavy as on the refract side, and then potentially the upside could be high as well. But that's something we work with our clients actively with, besides educating and assisting them, but in really making those qualifications.
Very good. Thank you for that, expanding on those questions. The next question, going back to candidate selection, again, this is from Karan. He's asking, is there any consistent markers seen in these successful candidates for acid re-stim? You mentioned iron sulfide. Is there any other telltale indicators that will be a good candidate? And also, do you perform any other treatments beside acid re-stimulation?
Yeah, so we perform any treatment the well needs. And I think that's why it's important to identify that up front, what the correct is. Almost like if you're a doctor, you want to, you're treating the patient, you want to make sure you know what you're treating for. I'm sorry, what was the first part of the question again?
The markers. Do you see any common key markers that will indicate that might be a successful candidate?
Yeah, so you're looking for near wellbore damage or any kind of scaling, essentially, or anything else you can treat for. So something that is blocking production, and as long as we can identify that, that's we can do that initially through an RTA. You can do it fluid sample analysis. These things to identify what is blocking production here from what's keeping this well from doing what it should be doing. So those are and that's going to be different from well to well. Iron sulfide in certain areas are it's a very common issue, and it's quite simple to treat for. Other places it's different kinds of scaling, but you have to have there has to be something wrong with the well that we can treat essentially, and we want to identify what that is.
Absolutely. So Dante, just to add to that, we've evaluated even just based off of large scale data, right? So that there's a lot of potential wells out there across pretty much all the basins, right? That are leaving behind reserves, right, on a day-to-day basis. So to piggyback on what Ivan said on the re-stim side, right? If you could just telltale signs. Ideally, if you have wells that exhibit some form of damage, right, and that well to begin with had a high potential level of recovery, right, but was underperforming to that effect, and then ultimately that there's still, based off of the potential recovery, there's still a decent chunk of reserves left to be had to make the economics work, right? So that sort of gives you initial framework of wells that would initially fit into this bucket, right? And then because we've evaluated tons of data and we see it, right? We look at thousands of wells, and what shakes off in most cases, almost like 50–60% of that initially fall into that pool, right? So going back to that mantra of we are now posturing into a more capital discipline environment, right? And we have to start looking inward and more creative in saying, look, there are a lot of stuff that we've left behind in the past because we're focused on offense, but now we're in a defensive posture, right? And so the mentality, the thought process has to sort of change as well.
I like that. That's very well said, FA. We used to be on offense and now we're more on defensive posture. I like that. That's
true.
So now I want to merge a little bit to some questions from Carl Montgomery. Carl's asking, well, before I get to Carl's question, to provide a little bit more context, you said that diagnosing the wellbore lateral or the lateral length and the breakdown pressures, depletion along the lateral, etc., was kind of a byproduct of your treatment because you're recording those pressures, you're measuring as you're applying your restimulation. So Carl's then asking, are you getting injection pressure in real time, or is this recorded on a memory tool or something similar? And secondly, can you control the injection rate into each stage, or is it injection rate controlled?
Yeah, so the standard data is memory based. So we run in on battery operated memory based gauges, and we log the data as we keep treating. We come out a hole, we download the data, and then we look at the efficiency of the treatment. There are technologies, if you run on coiled tubing, on a live coiled tubing, you can start having this stuff live, which is quite nice. And we're also working with one service provider to develop this to where we can have all the gauges live if we have a live coil. So that is coming. That tends to be, so that depends on the application, right? So you know, some like stay on US land, that tends to be maybe a little costly to have that. The memory gauges are a very economic way to get this data. But we have done couple of jobs where we have at least some level of live data downhole, and it's very nice to have. So certainly that's, like I said, that is also coming with live data on all gauges, as long as we can as long as we have some sort of live coil.
Yeah, and Carl's actually followed up with another question related to obtaining pressure information. It makes sense wanting to look at some diagnostic work after. So he's asking, have you recorded any pressure declines after the treatments so you can do some diagnostic analysis?
Yeah, so I think the short answer to that is, I mean, we'll do a treatment and then we stop pumping and the tool onset. So at that point, we're not isolating that stage anymore. But we do see, obviously, level changes as we keep treating, right? So we treat a stage, pressure is typically quite high to begin with, and then especially after the acid hits to the formation, I mean, assuming that formation reacts to the acid, obviously, we very often see acid, the pressure coming way down, and basically seeing downhole how the treatment is reacting to it. And I think also what's nice about it is you take away all the noise from friction, because that pressure is measured downhole right at the perforation. So it is the actual downhole breakdown pressure, if you will. And I think I forgot to address the other part of the question you had earlier in terms of rate. I mean, you can keep the rate, at basically whatever you want, as long as tubing allows it, obviously, for each individual stage. You can vary that however you want. That's really up to the operator.
But if you wanted to, you don't have to unset the tool after the treatment. If you wanted to, you could record some sort of pressure decline data.
Well, so the way our tool works now is it starts to unset once we stop pumping, and so we are done with it. So we have to have some positive fluid movement through the tool.
It depends on the pressure to be set. I get it.
Yeah, exactly. So yeah.
Okay. Very good. Well, it looks like we've covered all the questions from the audience. There is one more question from Carl. Do you know the rate into each stage, or what is the typical injection rate that you run per stage?
That varies quite a bit. It can be anything from, I think, 1 barrel a minute at the very low end, and up to like I said, 30 barrels a minute is the highest we've gone. But if I were to say on average, especially if we're doing acid treatments, we tend to be somewhere between 5 to 10 barrels a minute. But again, we can be below that, or we can go above it. It all kind of depends.
If we ask the question a little differently, because stages might vary a lot in length, depending on how much length you're stimulating, the better question would be, and I think he asked it earlier, how many gallons per foot do you typically pump, or what would be the rate per foot that you're covering on these stages?
Yeah, that also varies quite a bit, so it's difficult to give just a blanket statement to it. But obviously, I mean, in general, the more clusters you're straddling, the more clusters you're treating, you want to have higher rate and also some more chemical on it. I think just in general, and I think as we're if we're straddling a large interval at a time, that's also when we start looking into especially if we were conveying this in a rig. I mean, can we cross over to a large ID, especially on the vertical side, maybe do like a 3.5 or maybe like a 4.5 inch tubing on the vertical side, cross over to a smaller one throughout the lateral to maximize that rate. So yeah, I'm sorry, I'd be a little bit of wishy-washy, but it just depends so much on the application. But in general, I will say that, I mean, the more we straddle, the faster we try to pump, I guess, and the more chemical we try to place on each individual stage.
Absolutely, and no, that's very true.
No, this is gonna. Oh, sorry. Go ahead.
I'm sorry,
Carl.
Dante. Yeah. Let me just ask the question directly. Do you get a rate for each stage? In other words, if you knew the rate into that stage, you've got a pressure, then you could calculate a skin for that stage. But you're pumping at a constant rate. But do you know what the rate is to each one of those sections as it's going into?
Yeah, so the rate you're pumping from surface. If you're straddling, say, 5 clusters, you're not going to know necessarily the rate into each one of those clusters. But if you go down to the individual cluster level, obviously, then at that you're going to know everything. But you're always going to know the rate from surface that you're pumping. Yeah,
but if you knew how that rate was being distributed throughout the different clusters, then you could calculate a skin. You got the pressure. If you knew the rate for each cluster, then you could determine. But if you're just assuming that it's equal rates, or it's being controlled by pressure, then you could do some diagnostic work. That's all I'm saying.
Yeah, and I think kind of like the one case study we showed where we actually isolated each individual cluster. Like if you do it that way, you can get it 100%. If you isolate a fewer number of stages or clusters, you can make some assumption on it. And then if you isolate 20 clusters, it becomes a bit difficult at that point. But so I think the answer to that would basically be to focus the energy as much as possible between as few clusters as possible, and we can do that.
I can almost imagine, based on Carl's comment, I can almost imagine you could do a step rate, almost like a mini step rate test, and get initial skin before, the very beginning of your stimulation, and then final skin afterwards, and look at that skin removal.
For sure. Exactly, and Carl, I love where your thought process is headed, right? Because it's really in line with a couple of stuff we have in the works. I'd mentioned earlier about treatment optimization that we're working on with NSI. But even beyond that as well, we are also in the process of leveraging pre-existing data from a diagnostic perspective, right? In being able to reconcile some of the points that you're talking about, right? So absolutely. So, and that's something we anticipate, before the end of the year. Hopefully, we should have, we should be comfortable in coming back to present, or at least engage and educate everybody on that once we have that nailed down.
Very good. Well, thank you very much, Efe and Ivan. I really do appreciate the presentation today and sharing a lot of your responses during the Q&A. And thank you everyone in the audience for participating. Before you drop off, I do want to remind you, join us next week. We'll be hosting Adam McQueen and Tom Watkins with Advanced Upstream, and they will be presenting novel approach to reducing carbon footprint of drilling and completions through extended reach laterals. So be sure to join us. There's going to be some interesting discussion on hybrid completion designs, combining both plug and perf, as well as sliding sleeve or targeted pinpoint entry without sacrificing completion performance. So pretty interesting talk. I hope you guys enjoy it, and I hope you participate next week. Again, thank you so much to Comitt for sharing this talk with us today. Thank you, Efe, and thank you, Ivan, very much for being our guest speakers and sharing this content with us. and also answering all of our audience questions. And thank you to the audience for your continued support and participation in today's session. And we look forward to seeing everyone next week.
Thanks,
Again,
Dante.
I'll be sharing a copy of the transcript of the questions from today's chat. And if you wanted to expand or elaborate on any questions, we'll have the opportunity to post those on LinkedIn and continue the conversation on that platform in case anybody wants to interact with you a little bit more from that front.
Oh, sure. Well, thanks, Dante. Thanks, everyone. Thanks for having us. I appreciate it.
Thank you, everyone. And I hope everyone has a great rest of your Wednesday.